So this is my block diagram for my thermistor thermometer system. Uh, I will explain what the different components do and how it all interacts together. To start with, we have a while loop which is currently refreshing at 10 millisecond intervals, giving us 100 heads of a refresh rate. The number one component here in the block diagram, this is the thermistor itself. This is an analog input sensing the temperature. It's connected for the arrow into a stop loop facility, which then carries on towards an arrow handler and a reset option for my Rio. We also have a cancel button which can do the same thing once pressed. Now we have an input. We have two inputs going into this analog. So one input is measuring the voltage coming out of my Rio into the circuit, and then we have an input which measures the voltage after it has passed through the thermistor and the voltage divider with another resistor. So to calculate the thermistor's resistance, once we know those two values, we can use a formula which is just here. So it's voltage in minus voltage out over voltage out times the resistance of a known resistor, which in our case is 10 kilo ohms. And then we can from there we'll know the thermistor resistance. Once we know the thermistor resistance, we can then use it to calculate the Steinhart formula, or the beta formula for the actual temperature. So in here, for the Steinhart formula, we have our coefficients A, B, and C, which were calculated using an online calculator. They were plugged into this Steinhart formula just here, broken down into its basic steps. The output of the formula gives us temperature in Kelvin. From there we could transform this temperature into all the different SI units. We got Rankine, Celsius, Romer, Fahrenheit, and Deleuze and Romer. So those are all the different transition calculations for